Okay, so there's all of your example 1 stuff and just a bunch of things that go along with it. Example 2, where we're going to go next, the instructions say write in simplest form without zero or negative exponents. And that is going to be what you're going to use next. So I'm going to go ahead and flip. Without zero or negative exponents.
Chapel praise 10 to the 10 this time.
You guys will have to watch this later. 10 to the negative 2 times 10 to the negative 4. Guys, take a look at this with me. If you recall, when you have the same base, you add your exponents together. So that's the same thing as saying 10 to the negative 6th. Okay? But they say to you, write these without negative or zero exponents. And 10 to the negative 6 is the same as 1 over 10 to the 6th. But since they want us to simplify it, it has to look like that. 1 over a million. You're 1 in a million, guys. All right. The next one. That's their letter A. Here's letter B. If I give you some stuff in parentheses, like say negative 2 times 4 to the negative 2, all of that to the negative 2 power, you need to work your parentheses first. This becomes negative 2 over 16. Am I right so far? Negative 2 stays on the top. 4 squared is 16. Am I right? Okay. So this became negative 2 over 1. This became 1/16. That whole bit now needs to be raised to the negative 2nd power. This whole bit now needs to be raised to the negative 2nd power, which is quite irritating. That means this goes to the denominator as a 4 because it's a negative exponent. This, because it's down in the denominator now, goes into the numerator. What's 16 squared? Somebody want to tell me that real quick? And because we squared a negative, it becomes positive.
We put it in the
256 over 4. Oh, somebody jacked up my calculator. Look at what this thing's doing. Oh.
Wait, so when you raise a fraction,
64?
so when you raise a fraction, you flip them?
Yes, exactly right. Would you say it's the answer is 64? 64. Okay.
Oh, yeah, right.
Yep. Okay. So when there's a whole fraction being messed with by an exponent, it causes them to move into different locations. Okay. Here's a nice pretty one. Let's do this next one. I don't love these either, I'm not gonna lie. I just feel like it's a lot of work for something that maybe you might not use very often. But I have to teach it, so sorry. 2 to the 0. A to the negative 3b over, that should be 3. 3x to the negative 1, y to the negative 2. So 2 to the 0 becomes a 1. times, this becomes 1 over a cubed. The b doesn't move, so it's still b over 1. The 3 stays where it is, so that 3 is basically 1/3. That should be a 2, or that should be down there. X to the 1, because it's down in the bottom, moves up to the top as a positive. Y to the 2, because it's a negative, moves up to the top. I didn't make a very pretty problem. The top is bxy. The bottom, yep, squared, thank you. The bottom is 3a cubed. So when you work these like this, it's really, really handy to just work it across this way. But if you have a number like that 3 and it doesn't have a negative exponent, you have to keep it where it is. So that's why I listed it that way. X to the negative 1 move to the top, y to the negative 2 move to the top.
So anytime you're simplifying and like negative, it's flipped.
The negative exponent moves to the other side and becomes positive. It's very, very fun.
So if it's at the top, then it would.
Yeah, if it's at the top, it moves to the bottom.
So if it's, when it's always a negative at the bottom, it's always a negative.
It moves up to the top. Yep. All the negative exponents do is tell you to move them and change them to positive.
And then when it's up top, you
Move it to the bottom. Yes, ma'am, you got it. Here's an example of what 1 might look like. Like I said, I don't find this extremely exciting, but negative 2/3 to the negative 2 power. Okay, since it's a negative, and for all intents and purposes, we're squaring it. Negative times negative is a positive. Y'all agree on that?
Yeah.
Okay, so think about that and know that your answer is going to be positive because we're squaring it. The fact that we're negative squaring it only causes things to move positions. Okay?
So it's gonna be 9 over 4.
Yep.
Which is 2 over 4.
Okay, yep. So that is very, very important that consider the negative only with what you're doing. You're squaring it, you're cubing it. If we were cubing it, it would have stayed negative. And then this would have been 3 cubed, 2 cubed.
But if we were doing it to the negative.
Fourthing it, even. Again, back to even. So those rules still apply. Fundamental rules like that still apply. That hasn't changed. All right, the next one I want to do with you guys. I know I'm running tight on time, but man, can't skip anything here. What if you have a big fat mess here? I'm going to show you this one. A negative 2b to the negative 1 over a negative 3b negative 3. And there's actually a couple of different ways you can do this. I like to turn them all into moves and then multiplication. Like I know that a to the negative 2 in this thing becomes 1 over a squared. And b to the negative 1 becomes 1 over b squared. Okay? Or that's not a b squared. Becomes 1 over b. Okay? But all of this, notice I'm just working in the numerator right now. All of that gets raised to the negative first power. Wait, I should have left that b where it was because that didn't get moved yet. The b stayed where it was because it didn't have a negative, sorry. 1 over a squared, the b still stayed on the top. So they're just going to flip-flop. So now it's